Logics with propositional quantifiers are extensions of standard propositional logic that allow quantification over propositions themselves. In ordinary propositional logic, we work with propositional variables such as P, Q, and R, which stand for whole statements, and we combine them using logical connectives like not, and, or, and if, then. However, we cannot quantify over these propositional variables. Logics with propositional quantifiers introduce quantifiers typically written as the universal quantifier followed by P for all P, and the existential or particular quantifier followed by P for some P that range over propositions, making it possible to express claims about all or some propositions. One motivation for propositional quantification comes from expressive limitations of ordinary propositional logic. Certain patterns of reasoning involve generalizations over propositions, such as, for every proposition, either it or its negation is true, or there exists a proposition that is necessarily true. Such statements cannot be formulated within classical propositional logic without quantification. Another motivation arises in philosophical logic, where we may want to reason about logical laws, principles, or schemata themselves. Propositional quantifiers also play a role in the study of modality, necessity, possibility, contingency, etc., as well as in the foundations of mathematics and proof theory. The syntax of a logic with propositional quantifiers builds directly on that of propositional logic. In addition to propositional variables and standard connectives, the language includes quantifiers that bind propositional variables. Well-formed formulas are generated not only by applying connectives to formulas, but also by applying propositional quantifiers. For example, if A is a formula and P is a propositional variable, then the universal quantifier followed by P, followed by A, and the existential or particular quantifier followed by P, followed by A, are also formulas. These expressions should be read as for all propositions P, A, and for some proposition P, A, respectively. In this language, we can symbolize such sentences as a proposition is true if and only if it is materially implied by any proposition, and a proposition is false if and only if it materially implies every proposition. Semantically, propositional quantifiers are often taken to quantify over propositions, which are typically identified with sets of possible worlds, functions from possible worlds to truth value assignments, or valuations, depending on the semantic framework. In a simple truth-functional semantics, a valuation assigns truth values to propositional variables. In possible world semantics, the interpretation of a propositional variable is often taken to be a set of possible worlds, the set of possible worlds in which this variable is true. An alternative is to use a kind of substitutional quantifiers. According to this view, for all P, A is true if and only if the result of substituting every free occurrence of P by B in A is true for every sentence B in our language. While there is a P, A is true if and only if the result of substituting every free occurrence of P by B in A is true for some sentence B in our language. The proof theory of logics with propositional quantifiers can be developed in several ways. Natural deduction systems can be extended with introduction and elimination rules for propositional quantifiers, similar to those used for quantifiers in predicate logic. Axiomatic systems are also common, often involving schemas that capture valid principles of propositional quantification. Semantic tableau methods and sequent calculi have likewise been adapted to handle propositional quantifiers. Logics with propositional quantifiers can be extended in many directions. One important example is modal logic with propositional quantifiers, where quantification over propositions is combined with modal operators such as necessity and possibility. Such systems allow us to express claims like, every true proposition is possibly true. There exists a proposition that is necessarily true. A proposition is necessarily true if and only if it is necessarily implied by any proposition, and a proposition is impossible if and only if it necessarily implies every proposition. Other extensions include intuitionistic versions, temporal versions, and combinations with epistemic or deontic logic. Logics with propositional quantifiers significantly extend the expressive resources of propositional logic by allowing us to quantify over propositions themselves. While this added power increases logical complexity and raises subtle semantic and proof-theoretic issues, it also opens up new ways of formalizing philosophical and logical reasoning. As a result, these systems occupy an important place in contemporary philosophical logic,